So I'm Glenn. I'm from Norway. I work at a small startup right now doing legal stuff. And I'm going to talk about how to build modular monoliths. If anyone don't want to learn about that, you should change rooms right now. You're going to suck if you don't. We're going to do a mix of, I'm going to talk a little bit about things. We're going to do I'm going to do a bunch of coding. There's a GitHub repo you can download later that you can follow along in the coding. I'll give you some exercises and tasks. And in a couple of days on the repo, I'll put up some labs that you can do after the conference is done as well. This thing is slipping off my ear, but I think it'll be fine. So, anyone build a monolith that was modular or not? Anyone build microservices? Which one do you like? Who likes the monolith better? Who likes microservices? Nobody likes microservices. Why do you hate microservices? Why do you hate microservices?
Basically.
What was that you said, the first part?
They are basically too complex what we are trying to
They're
achieve.
too complex for what you're trying to achieve. Yeah? So, yeah, this is our company. So, monolith is a definition. Let's define what a monolith is. It's a noun. It's a large single upright block of stone, especially one shaped into or serving as a pillar or monument, or a large impersonal political, corporate, or social structure regarded as indivisible and slow to change. I mean, it's not hard to apply these terms to some software most of us have been a part of for some reason. Like a monument for all the consultants that were on the project for like 6 months before transitioning out of it. Large and impractical, impersonal, corporate, social structure. Yeah, I worked on that app. So, indivisible, slow to change. Anyone work on a monolith that was slow to change? Yeah. Well, I'm guessing you did because you thought, oh, let's go there and learn how to build a monolith that's not slow to change. The software definition is an application that is built and deployed as a single unit. It's self-contained and it is independent from other applications. Saying that I take this application, I take the entire application, put it here, and it runs on its own. It doesn't need a series of applications around it in order to actually run. So the problem isn't the monolith in itself. It is that complexity that is unbounded, that has no limits, that is allowed to go freely and work exponentially inside of it. And we get, the technical term for this is a big ball of mud. And what can we say, the common knowledge is that all monoliths devolve into this ball of mud. Start out with the best of intentions, and after a while, yeah, it still sucks. Spaghetti code, the massive files, really, really long, disorganized code, some over here, some over there. And every single change risks breaking 1,000 things. Anyone make a change and you're like, I have no idea what breaks. And the answer to that problem is in two more definitions. There's two words we want to talk about. One is cohesion. Anyone heard the word cohesion before? Yeah, a couple of you. Yeah, nice. Good crowd. Again, it's a noun. It's the action or fact of forming a united whole. And the sticking together of particles of the same substance. I like to call it things that belong together are together. These things here, they belong together, they are together. So I just got a new kitchen. It was many weeks of pain and ready-to-eat meals, but now we're getting there, and now we're moving stuff into the kitchen. And cohesion is a huge part. Like what goes in the different drawers. In this drawer, we have stuff that belongs together. So when I want kitchen utensil, I'll go in that drawer. That's where all those ladles and wisps and all of those things are in that drawer. All the glasses are in that drawer, all the plates are over here. We have cohesion. Things that are together or belong together, they are together. And vice versa as well. If I go somewhere, I expect to find the same things. I don't expect, whoa, why do I have all my forks next to all my glasses? It doesn't make sense. Another word is coupling. It's a device for connecting parts of machinery or the pairing of two items. In your code base, you want a high degree of cohesion and a low degree of coupling. This coupling ties things to each other. So in my kitchen, in every kitchen, have you heard of the kitchen triangle? So the kitchen triangle is your cooking space, your sink, and your fridge. They form a triangle, because those are the three things you move along with whenever you do a kitchen, whenever you work in the kitchen with making food. You want to keep that triangle pretty tight and optimized, because those things are, when you're making food, the stove, the sink, and the fridge, they're highly coupled. Rarely can make food without getting into all three of those. So we want to keep those things tight. Code is coupled when it references other code. So if you, in your class, the hardest coupling is new. So when you do var something something equals new something. Then you have a hard coupling between this one class and the other concrete implementation of that class. Stuck together. Oh, by the way, how many here work with or are familiar with .NET? Okay, pretty much all of you. Great. Because you were a bunch of Java folks, somebody would have a bad time. Just thought of that as like, oh, maybe I should check. If we have high degrees of coupling all over the place, it makes it hard to change stuff without affecting other stuff. So it's hard to make a change here if a bunch of other things are directly dependent on that thing. So we have in our application, as we make more changes to it, we add stuff, complexity goes up. This is practically a law of nature. Entropy and all of that. As you introduce new bits, it's really hard not to have any couplings. We create some more connections between these pieces. The problem is that they don't increase linearly. No, they increase exponentially, because the more things you have, the more things you can have couplings to. And if you add more stuff, you can get even more couplings between the things you already had. So one thing doesn't add just one coupling, it adds a multiple of couplings. And after a while, your application becomes really hard to manage, and that's when we get the big ball of mud. What we have to do is to keep introducing complexity dampening measures. Complexity starts going up, we need to do stuff to make it go down. When complexity goes up, we have to do something and make it go down. Either that, or we stop early, making really small apps. And that was the thing that people started doing with microservices. These microservices, and they kept these really small, there was a limit to how great the complexity inside the application could be. You wouldn't put everything in it. So you put some stuff into it, and it was like, yeah, we're done. This thing does what it's supposed to do. This is micro, small, manageable piece of thing that I can do. And we stop like here. We got this complex. Great, we're done. And then we add another one, and that gets a little bit complex. And you could go in and to one microservice and work on that in isolation and be really happy. Except we traded that complexity for the complexity of the whole system. We increased that a lot. But it was really hard to make hard couplings between stuff inside one microservice and stuff inside another microservice. What people did instead is that they made hard couplings between the actual microservices, which was a worse problem. And they now made a monolith just a distributed monolith, which is the worst of both worlds. What we want to do is achieve some of the same effect that you do with microservices, but instead of putting it into services, we'll put it into modules. So a module, again, definition, a set of standardized parts or interdependent units that can be used to construct a more complex structure. Or a detachable self-contained unit of a spacecraft. Pretty cool. Let's make some spacecraft parts. The first problem you have to solve has nothing to do with code. Absolutely nothing. It has everything to do with the business and setting boundaries. Making boundaries between the different modules, or saying this part of the app is one part, this part of the app is another part. Anyone familiar with domain-driven design? Yeah, about half, third, thereabouts. We're gonna scrape the surface of it. If you're familiar with it and know all of it, bear with me. Let me know if you think I'm really wrong. But the skills you learn in domain-driven design come in really handy when you're defining your boundaries. So what is boundaries? Imagine your application being sort of like a city. Every city has different neighborhoods. And some have residential zones, they have office zones. There's some neighborhoods that are worse than others, better than others. Same way your app has distinct areas of functionality. So these are, I found the neighborhoods of Vilnius online. So I understand we're in the business district. A lot of tall buildings, a lot of offices, a lot of huge Europa supermarket. I went to a site that said Hood Map, which shows you all the bad things about every neighborhoods in some cities. And apparently the big square on between here and the Europa thing was just full of obnoxious teenagers. I don't know if that's right or not, but this area is very different than the old town. There's a totally different vibe, there's a totally different content. And then you have, I understand you have the new town next to the old town, which is also really old, but is newer than the old town, so the new old town, which has a slightly different vibe again. And then you go further out, you get more greener neighborhoods. They're all different. And if we stretch the metaphor a little bit, the communication between these neighborhoods is pretty well defined. For some of them, they're really well defined because you have a river going through the city, so it's like there's one bridge there and there's one bridge there. But you have major roads that most people should take going to and fro these neighborhoods. So communication between these neighborhoods is in essence limited to whatever roads you made and whatever public transport runs on these things. Your city is your domain. Your neighborhoods are what we call bounded context in domain-driven design. If you're running an e-commerce application, you might have areas such as ordering, customer management, product catalog, billing, shipping, whatever. Each of these is a separate neighborhood in your app. But clearly defining these boundaries, we can make it a lot easier to manage the complexity because we not only define these boundaries, but we also severely limit and control the way these boundaries communicate. So here our domain is e-commerce. That's the business domain we're working in. And these things here are your bounded context. Now people have, when they're working microservices, say, well, one microservice is one bounded context, which is not right. They are two different, they are orthogonal topics. So bounded context is an architectural business construct, while a microservice is a technical unit of deployment. These things may overlap, but they really have nothing to do with each other. Creating these boundaries is often the hardest thing to do. And you've got to get them wrong. And that's also one of the advantages a monolith gives you, because when you get it wrong and you want to change your boundaries, it is easier to do that inside a single code base, single application, where your IDE, your editor, can help you with moving stuff around, adjusting namespaces, shipping these over here, these over here. It is an easier task than doing this between two different applications and two different repositories, moving things back and forth, organizing how things communicate. If we just move them around, we can just update references and refactor a code and everything is updated. Bounded contexts are the boundaries of meanings. They define the meanings of words. So inside one bounded context, a word can mean something else than in a different context. So if you have if you're running Uber, for instance, the word booking might mean different things to the customer and to a driver. So a driver gets a booking and a customer gets a booking. Those might be two different types of bookings because they're in different places, different contexts, different actors working with them. Inside one context, we all speak the same language. Business, people speak one language. Documentation uses the same language. All the emails we're sending out inside, all of these, whenever we're inside one context, they should mean the same thing. So, how do we discover and define our boundaries? Well, there are many ways you can do about it. People have done this way before DDD even arrived. You have to talk to people. I'm sorry. It is of utmost importance that you, as developers, understand the business domain. Understand what the words the business people use and what they mean in different contexts, and know that when that guy uses that word, that's different. When he uses that word, that's different when she's using that same word, because they're working in different places. You need that understanding to solve the everyday problems you're going to run into. Alberto Brandolini works a lot with DDD, and he has that. It's developers' misunderstanding, not the expert's knowledge, that gets released into production. So have you ever played the whisper game? Or they're called telephone, where I whisper something to you and you whisper it, and we all whisper it to each other, we'll go all through the room, and then you say what you heard, and it's something completely different than what I said. And you have different games where I whisper something to you, and you make a drawing, and give it to the next person, and they interpret your drawing, and then they whisper what they thought you'd think your drawing means to the next person, and then he does a drawing, and it goes back and forth like that. It's really, really hard. So we're going to do a little exercise here. Find a partner, 2 and 2, or 2 or 3, doesn't matter. And one of you will think of a song. And you will play that song to the other person. The other person should guess what song it is, but you're only allowed to play it with one finger on the table. And the other person should guess what song it is. So find a partner or 2 and play each other a song. You can just turn around, there's one guy right behind you. Do it a little bit and swap around. The other person can try to play you a song. Is it frustrating playing the song and they're not getting it at all? Anyone managed to get the song? Yeah, which song did you play? Yes. There's 2 songs. We Will Rock You is one. That one has a pretty good rate. And there's another one, I can't remember which one that is, but there's 2 songs that people keep getting. All the other ones, like, no way. And the worst part of it is, it feels so frustrating because how can't they get it? Because it's so obvious. Because you have the rest of the song in your head. So for you, these things have a context, right? So for you, these things match into an existing picture or audio you have in your head. And of course they should be able to understand what song you're playing. Except it's really, really hard because the information that is actually flowing to the other person is super limited. And that is the problem when people try to explain what they know to someone that don't know it. They have all this context in their head and they forget that the other person does not have that. So they'll say, oh, it's like so-and-so. And every now and again they'll think, well, yeah, but it's obvious that sometimes it's not, or something like that. I had one like, I asked, confirm, so it is every single time it works like this. And they go, yes, every single time. Well, except sometimes. It's completely different. And then they have the nugget. But that doesn't happen very often, so that can't be hard. Like that has anything to do with it. If it happens, that's the hardest. Like yes, so if it happens like once a year, that is easier to make. Like no. So it is of so much importance that you regularly check in and work with the business to keep that understanding flowing, and change your this doesn't work like that. Oh, okay, that works differently. So and maybe boundaries need to move. One pretty good way of working through this is something called event storming. Has anyone tried event storming? Yeah, a couple. Event storming is probably invented by 3M for selling more post-it notes, because you use a shit ton of post-it notes when you do event storming. And you don't have just one kind of post-it notes. No, you have multiple colors of post-it notes, because colors have meaning in event storming. Essentially, it's a collaborative workshop with developers and the business going through and you start on the top, like what are the things that happen in our domain? The events. These are the orange post-it notes. What are the things that happen? Like user signed on, user logged off, order created, order placed, ride booked, ticket purchased, payment completed, all kinds of those things. And then you have a whole thing about what happens around these events, what happens before them, in which order do they happen. And you can do a whole bunch of stuff here. Getting the boundaries set up, you can do what is known as a big picture event storming, the big picture exercise, which is looking at the events and seeing, okay, the events are meaningful changes in the state of whatever system you have. And these changes are important to the business. So there's a little level. You have to be this high to go on this ride. And they need to be handled by your application somehow. And so we order all of these events, saying if you have an e-commerce, you start somewhere, it's like, okay, product viewed, a product was added to a cart, the cart was checked out, and we received some payment. Organize by time, start with some, add more events go in between here. The goal here is to collaboratively draw out the significant events that occur within your domain. I think a little bit, does anyone here actually actively work with an application today? Yeah? Does anyone not work with an application day to day? Okay. So try to think of events that happen, meaningful events that happen in your application. Things that have an impact on your business, that moves a needle somewhere. And try to think, okay, what happens before that? What happens after that? What are the different events that are happening in my application? When you've done an event storm, you get a board that looks a little bit like this. And this looks horrible if you're not familiar with event storming, but if you're familiar with event storming, this looks like this is awesome. This is beautiful. There's so much information here. What you're looking for are the pivotal events. The events that have meaning for two different things. Events that finish a process and start a new one. For instance, one event could be shopping cart checked out. Then you're done with the putting things in the shopping cart process. I'm going over to a different part. I'm going to now go over and actually make an order. And maybe the payment initiation is a different part. And maybe there's other processes that are not connected that don't start, like updating prices, which is not handled by the customer, but they're handled by a different person. There's no hard and fast rule here. It's an experience-based skill, and you're going to get it wrong, but that's why we build it in the monolith, because that makes it easier to change. There are some guidelines we can follow to define boundaries. For instance, looking at what behavior is likely to change. Which parts of your system are likely to evolve independent from other parts? Like, okay, yeah, this thing here, these things, we're going to be working on we're going to be iterating on those a lot more than these. This thing is pretty set. Here we're going to be doing a lot of work, adapting, experimenting. Okay, maybe that's a boundary. What data changes together? Like if I update this, does this also update? If I update stuff in my catalog, does that affect my orders? Maybe, maybe not. If I update stuff in my catalog, does that affect my shopping cart? Yeah, probably. And also what data and behavior depends on each other, saying, oh, elements that are tightly coupled in terms of data and behavior are often good candidates for being in the same context. For instance, in an ordering system, the order lines, maybe the inventory information, maybe payment information, they're all tightly related. They could start off in their own context. Or maybe the system is more complex and we have a different context for the shipping or the payment. And that's where you need that domain knowledge, like know the business. Anyone familiar with transactions? Transactions are things that happen or don't happen as a unit, or data changes. Database term, we save a bunch of stuff in the database, and if it's all inside one transaction, either everything is saved or nothing is saved. It makes no sense to have half an order without order lines, for instance. So maybe an order and its order lines should be updated together. They're their unit. But I can update inventory without making sure that all my orders are updated in the same go. Anti-requirements, things they shouldn't do. Like creating an ordering context, maybe we should not worry about authentication. Maybe that should be handled by something else. Sometimes it's easier to define things by saying, we're not going to do this. That's gone at least. Like I said, engage regularly with the business, talk to them as you go along. It's not you have a meeting and then you start building the app and 6 months later you have a surprise party. It's like, hey, look what we built. And they go, oh, that's nice, and completely wrong. You're going to do assumptions along the way. Make sure to go back and look at your assumptions and figure out, like, okay, that's actually not the way we did it. Look at assumptions that stakeholders have. Ask why. Why is it like that? When you've put up a bunch of events in event storming and you have a result, go to the end result and says, why did this happen? What made this thing? Oh, okay, and why did this happen? And why did this happen? And why did this happen? And go back and forth. The edge cases, the ones that don't fit. Keep asking those questions and rinse and repeat. But microservices. Now, that work with setting boundaries, you have to do that whether you're making microservices or a modular monolith. Either way, that work has to be done. Microservices will give you that hard border between services, which can be useful, but they also have this metric ton of complexity. They have stuff like, how do we communicate between microservices? Is the network, there's a list of fallacies of distributed computing. Things that people assume are true, but are actually false. Stuff like, the network is always present. No, it's not. Network transport is free. No, it's not. There's time and even sometimes cost. So when splitting things up and moving them around, you're deciding to play the game on hard mode. So we're not going to use microservices. So how do we organize our code? We're often, as developers, we're orderly people in our code. Not so much on our desks, for some reason. Does anyone have a clean desk? Does anyone work in a place with a clean desk policy where you have to clean your desk every day and then come back? I hate those places. Like, I don't think I could ever. I could, if I worked in those places, I would be the person that HR hated the most. But in code, we like to have orderly fashion. We like to have things where we expect them to be. Some of us like making systems. We're not just as good at following up on those systems. I like cleaning my desk. It just devolves into a natural state of chaos very quickly. But I like having the system. Now I bought a 3D printer and I'm going to make a system to hang stuff on my wall. That's going to be great. Yeah. So, but we should have some structure that makes it easy to know. So, brings me to another point. What or who is the recipient of our code? What or who do we write and organize our code for? Ourselves? Colleagues? Other people? The client? The compiler? We write code for other people. And other people includes you in 6 months. It's like, oh, who the hell wrote? Anyone done git blame? Like, who wrote this shit? Git blame. Oh, I did. 6 months ago. Oh, right. This is horrible. So we write code for other people. And we want to, all our code, David Whitney, who's here for this conference as well, has a great talk about language and code. How do we communicate with our code? You should look that up. It's on YouTube somewhere. Organized by business first, then technology. There's too many that have the domain project, and then the infrastructure project, and then the application project, and then the whatever project, and the extensions project, and they organize their code by technology first. But we rarely work in a technology-first fashion. It's very rarely that we say, well, I'm going to work on this application, I'm going to make all my extension methods first. And when I made all my extension methods, I'm going to make all my types, all my value objects, I'm going to make those. Then I'm going to make all my controllers. And then I'm going to make all my domain objects afterwards. And then I'm going to make all my database stuff. Nobody works like that. We have a problem and we need to solve it, and solving that problem, we work through the whole stack. So this is my lith without the mono. So this is one way of organizing code where you have different modules. Each module is one project. And there's, within each module, we can split things in concerns a little bit more. I like this way of organizing my code. You could also, if you wanted, instead of projects, have folders and have one project just with a bunch of module folders and then folders below that. That works. It used to be that if you had a whole lot of projects, your Visual Studio would go really, really slow. That problem is very, very much solved by now. Of course, we can still have a ton of projects, and maybe then you're stretching the limits of what your monolith should do, but still. When you compile now with the parallel compilation with .NET and the way that it can see what things have been changed or not, you can actually get faster compile times with lots of projects, because it will not recompile projects you haven't changed. It will just recompile whatever you did. So, we're going to take a break in 5 minutes because there's a coffee break. There's a project on GitHub called Practical Monoliths Build Stuff. If you don't want to write all that, you can go to henriksen.no. There's a GitHub icon, and you can go to repositories, and it's the top repository. But let's take a look at that. Not every project has to be the same. For instance, here let's look at an Explorer first. Open folder in File Explorer. So I have a source. I like a source folder and a test folder. None of this is written in stone. I like having my solution file at the root of my project. And then I have source, I have tests, and then I'll sometimes have docs, I'll have libraries, I'll have other stuff. And in source, I have all my projects. And this application is called Commerce because it's an e-commerce site. So it's commerce.features, features, modules, whatever you want. It doesn't matter what you call it, just call it a name that you and your colleagues are okay with. And I have a web. Oh, that one shouldn't be here. Move that. Oh, that one shouldn't be there either. So in, for instance, features customer, there's an application folder, there's a data, there's domain, there's hosting. Within data, I have all my DB context, my migrations, all the stuff related to my databases there. In the domain, currently have a tiny domain of a customer object. Hosting, we'll get back to that, some infrastructure stuff. And then application, I'll get back to what that is as well, but that's the top layer of my app. My web doesn't have a lot. It has some basic components. It has my app file, which is the root of my application, which has the routes. And then I have the routes, which say, here's my routes. What are you not authorized to go to login? And then I have an auth page that just shows you're logged in. And I have error page. I have a home page, and I have a weather page for showing some temperature data. This is the Blazor template out of .NET. It's not very exciting. What is more interesting is that I've split some stuff out, because I've ASP.NET identity in this app, but it's not part of my web application. I split that out in the identity.components project, where I have my account pages, all of these pages here. External login, /account, external login, lockout, login page. They're often its own project. So if you're going to work on the login pages, you'll go to the identity.components where all the Razor components are. This is a Razor server-side rendering, is no interaction, not interactive here, so it's just renders web pages and pushes them to client. And then I have the features identity module, which has the data part, the DB context. It has an application user object with no content so far, and has a little bit of application layer. So if I want to work on identity, I'll go here to work on the domain, the way identity works in my app, what I've built on top of the ASP.NET identity, that's over here. If I want to work on the pages, I'll go on the side project with the components. They're split in two projects because these are Razor files, and this has to be a Razor project, and that has consequences. So this split in two in order to make these things work better together. They work better slightly apart. So they put all the Razor components in one place and all the other stuff in another place. You could probably combine it, but find that when you start adding a bunch of features or dependencies to your components library, they tend to act out. The customer, they don't have that yet. They don't have a separate thing. So one of the things we have with our modules, we want to keep those separate. But some things we want to share across the application. And that is, we sometimes call that the shared kernel. That is a name that comes from domain-driven design, Eric Evans. In this case, I put it in the commerce project, which can have a bunch of common thing. In this case, I'll just have, what is it, backup TMP? Let's get rid of that, we don't want it. There's a folder here called shared kernel. These are things that are reused across modules. I like to put some common value objects in here, for instance, stuff like address. Who's familiar with value objects? Okay, pretty much about 2/3 of you. We have two different kinds of objects. We have entities, which have an identifier, and we have value objects, which do not have an identifier. Value objects are identified by all of their values. So your address. You live on a street, you have a postal code, and sometimes a postal place. This is a very simple address. It doesn't account for countries and all kinds of stuff. But there's nothing more than those things that will identify an address more than these things. It's the street name and number, it's the postal code and whatever area it's in. You can't it's that, and then there's the number 2 of the same, which are two different addresses. It doesn't make sense. Same with email. Your email has a value. It's your email address. My email is glenn@henriksen.no. You need 0 more information to identify that email address. If I have 2 different strings with my email address, if they're equal, they're the same email address, right? Those are value objects. Well, a customer is not necessarily defined by all of its contents, because you can have 2 people with the same name, so you need some kind of identifier that says this field signals that this is that particular customer, the ID field. So we'll have entity. I have a base class here, entity, which has an ID. In this case, I just have a GUID. I'm not doing that here, but there's a school of thought that I very much like, but it adds a little bit of complexity to it, so I'm skipping it for this one. Instead of using GUIDs for everything, you use strongly typed identifiers. So you would have a customer ID. You would have an order ID, which is a particular type that cannot be misrepresented. It cannot be mistaken for some kind of other, but a GUID is a GUID is a GUID is a GUID. Like you can put a GUID in anything. But you can say, hey, this thing is not a GUID, it is an order ID. And an order ID is completely different and not interchangeable at all with a customer ID. So I get strongly typed identifiers. Those identifiers I would also put in my shared kernel, because I would use them throughout my application in all layers. So a product ID would be a product ID wherever I looked. But an address or an email, these are value objects, and you can do stuff with here. This is record, so I get value compare for free with .NET. I can have special types of emails. I have an email.empty, which is just a new email with an empty value. And I can compare 2 email.empties by their value, and if they have the same value, they're the same. So an email empty is the same as another email empty. I have an invalid email, so I can say, well, this email is invalid. So I can add meaning to my value objects if I want to. And I have some stuff to validate. Whenever you do this, you need some form of conversion usually, because you don't want to return JSON and stuff like that, but we won't spend a lot of time going into those details today. But if you're curious about those things, come find me after the talk or one of the other days, and I'll happily share a lot of, I'll talk your ears off about that. An important concept within DDD is the concept of aggregate roots. So an aggregate root is or an aggregate, let's put it that way. An aggregate is a graph of objects. So we have a series of objects that belong to each other, are related. So we have, for instance, an order, when we have some order lines, and we have some other information attached to that. So there's a bunch of objects. Order has a customer, has an order line, order lines has a product, stuff like that. This whole graph is called an aggregate. And to simplify things, we work on an aggregate as a whole and from the aggregate root. So this object on top here is what we call the aggregate root. That is the thing we store in a database. That is the thing we act on. So in order to talk about these or signal these objects, we use base classes. So we have a base class of an aggregate root. Should be abstract, so you can't instantiate it. You should never be able to instantiate the aggregate because it doesn't make sense on its own. It's just a base class, which inherits from entity, which has the identifier. I've made some opinionated choices here, so all my entities has a GUID as an identifier. There's pros and cons about that. I won't go into it unless you're really into it. But that's a choice I've made. You can make another choice if you want. It's not set in stone. We have some exceptions can go in here that can be common all over the place. We can have the same exceptions. If you're using a result-oriented architecture, you would have different errors for your results would go in here if you're familiar with that. If you're not, never mind. And we have some common infrastructure that can be used in different places. Stuff shouldn't go in the shared kernel unless it's really shared. It shouldn't go in the shared kernel just because maybe it doesn't fit quite here. Maybe it should be things that are truly common. Now, one of the big things, persistence. How do we store this stuff? Some people have asked questions that I've alluded to that they're on this page already, but each module should be autonomous, which means it should be able to act on its own. And that means it should own its own data. This allows each module to evolve its data model independently and prevents those unintended data access across module boundaries. You should never, and I stress this, never, absolutely never do integrations through the database. Like, yeah, I'm just gonna, that table over there is nice. It would be a shame if someone changed it a little bit. You never share stuff between information between different modules, application, whatever, through the database. That is a source of pain and suffering. In .NET, if you're using Entity Framework, we'll make separate database contexts. In this case, we have the billing context, the catalog context, and we can always use separate databases for each context. That is the safest boundary, but that gives you slightly more hassle than you need. It's not very cost effective, and it makes it harder to get a unified view of all your data, and sometimes there's stuff we haven't built yet, so we have to drop into Data Studio and do some ad hoc queries, and that becomes really painful if your data is spread across multiple databases in Azure and you can't do cross-database queries. That sucks. What we do instead is that we put it in the same database, but we use a thing called schemas. So in a single database, we can use schemas and say, hey, schemas are like a namespace or a folder for your data in your database, but it has only one level. You can assign permissions to them if you want. You can say, hey, these people are allowed to access this schema, this part is allowed to access this schema, but not that one, and so forth. One advantage with schemas is that you can make ad hoc queries across schemas. So here I'm asking from ordering.orders, that's the ordering schema, join customer management customers, which is in the customer management domain. So I can do these queries if I want to across. I shouldn't do this in my application, but I can do it ad hoc if like, oh, I need to troubleshoot something. I need to look into something. Sometimes we do need to go spelunking in the actual database to solve problems. Another thing is that you should never have permanent access to your production database with your account, just log straight in. There should be a process for that, but that's a different matter. So let's look at code. If you pull up your code, we'll go into let's go into customer, under data, customer DB context. There's a property here. Can you see in the back here, is it too small, too big? Pull it up a little bit. There we go. That was a bit too much. I can't tell myself where we are. So I have a customer DB context, and I have a schema property which is set to customer. I inherit from something called my domain DB context. So I have a base class for my DB context. Here I have a public abstract string schema. If I have an abstract property, that means it has to be overridden in the base class. So if I don't override this, I'll immediately get an error saying that abstract inherited member string, comma, circle, and infrastructure data domain DB context schema is not implemented. Abstract inherited member string, comma, circle, and infrastructure data domain DB context schema is not implemented. It says it twice. That's how mad it is. So we tried to make what we call pit of success, where people are led to doing the right things and the compiler will remind them to do the right things. Because developers forget. They are human and they don't, even though we assume people are adults, sometimes they make mistakes and they forget this thing, and then you have what's known as the broken window syndrome. Are you familiar with the broken window syndrome? Have you ever lived somewhere or been somewhere where there's been a car or a building that was abandoned forever, for a long, long time? And nobody touches it. It looks just the same. It's like it's there, but nothing happens to it. It's just abandoned. Then one day, someone breaks a window, which doesn't get fixed. And then everything goes to shit. Because the next day, 3 more windows are broken. And because people say, oh, nobody cares about this thing. We can do whatever we want. It doesn't matter. That is the broken windows. If you break a window and you don't fix it, you're telling everyone that I don't care. You can just do whatever you want. I don't care. Same with our code. We have the broken window system of code. If we like, well, I'll do it this way this time. Well, it's fine. And then other people will see that and go, oh, so we can do that. Oh, great. Well, I don't have to care about that. Then I'll screw it. And then I have in my on-model creating, in my domain DB context, I say model builder has default schema. So if I inherit my DB context, inherit from domain DB context, I have to set the schema. And once I've set the schema, the domain DB context will take care of saying, yeah, okay, yep, I will set that schema. I have to remember one thing though. I have to remember to call the base on model creating somewhere. I have to do that. So I like putting my migrations next to my DB context. So let's go into source. customer. If you have multiple contexts and you're doing migrations, you have to specify which context you're working on. If you don't have your database DB context in your web project or your startup project, you have to specify where your startup project is. And you can also specify where do you want to put your migrations. That part you only have to do the first time. Afterwards, it will just figure out where the existing migrations are and put it next to it, next to that. Let's clean this up. No, never mind. Oh, there's a migration. Right, we don't want to touch those. Yes.
On the startup, is there such an option? Would it be still possible?
Yes, you don't want to do that. It's possible, but you don't want to do. You never want to have your applications run your migrations. You want your migrations to run in a more controlled fashion outside. But you can always do it. We have some tests here that do it. Are you familiar with the test server in ASP.NET? So in ASP.NET, we can do what's called test server or the web application factory, which will stand up an in-memory version of your web server, and I can get a HTTP client that I can call it with. Here we override some of those features. And I use, when we want to test, so there's people have written, legacy code is code without tests. So we want tests. And we have two different kinds of tests. We have unit tests and we have integration tests, and then we also have the third one, which is end-to-end UI tests, which are harder to get right. Unit tests sometimes seem like a lot of work for very little return, but they're really useful when you're working with complex domains and business logic. They're super useful for that. But sometimes we just want to say, does this shit work? And these integrations test here, where you test the call at endpoint and then just get everything tested from the down to the bottom and up again, they're very useful because you can test a lot of code with very little effort. This particular part, so what we do is that we set it up. We remove the DB context registrations that are already in our code. And then we have, in this case, I'm using something called test containers, which will spin up a Microsoft SQL Server in Docker. And then it will give me some database name that comes from whenever I kick this off. I'll show you where later. So, and then I'll add, actually we don't want that. Yes, it's not an in-memory. And then I add DB context with this new connection string, which goes now to my test container that was just created for my different contexts. And then I migrate like this. You have to do it once for each context. So I get all the different DB contexts, and then I just migrate every one of them. In this case, they're all spelled out. As you get more, you can make some code to find all the ones and just run it. Yes?
For databases or integration testing instead of
I don't like it. It's easy, it's nice, it gets started, and there's subtle differences which makes them not the same. So, for instance, the EF Core in-memory database provider, it's a key value store, it's nothing else. It has 0 foreign key constrictions, all of the constraints you put on, they don't exist at all. Oh, great. Well, we'll use SQLite then. SQLite doesn't support schemas. So then you have to do some work to get different things going for different databases. So each schema needs its own database. Migrations are different. These SQL generated migrations are different from SQLite and your production. Especially with test containers, getting an environment on your machine that is very, very similar to the environment you have in production is now super easy. I'm using Microsoft SQL here. It would be just the same if I use Postgres, use MySQL, MariaDB, whatever. They all exist in different containers. DB2, whatever. I can run them locally on my container, and I can test against the database that acts and moves the same as the one I'm using in production. And it has saved my butt a couple of times, and I have had my butt handed to me by SQLite or my in-memory database a couple of times. So yeah, there's ways of getting around it because you can use the ensure created instead of migrate, and then you can have your migrations for a SQL server, but then you run your test with SQLite, but then you start differing the way things work. Now, when I run my test, I can also verify that all my migrations actually work. So everything happens pretty fast. There's always a little bit of a delay. So let's, yes, in my test, let's just do my integration test. I have a base integration test. In this case, I'm using, let's see, where did we go? Yes, my SQL Server container fixture. So this uses a setup fixture and a one-time setup. So this runs once for the whole test, run. It runs once for all the tests. Not for each test, just once right away. What it does, it creates a SQL Server container, builds that, all the defaults, get the connection string for it, and then save that in connection string. And then I have a teardown where I dispose of that, and that goes away. So if I go into my features, let's go to customers, endpoints. Here's some customer endpoints. Let's run all my tests. Don't want to run my test. Fine, be an asshole. So it uses a little bit of time starting up, so it's not like super fast, like inner loop kind of thing. So it uses to spend some time in SQL container fixture here, but once it does that, tearing down and setting up new databases is pretty fast. So it's slow when you have like 2 tests, but if you start getting a lot of these, the overhead is pretty small. So it uses, what is this, 12 seconds to boot the SQL Server container, and then 3 seconds to run my tests afterwards, and that's mostly overhead. If we run Docker desktop, it creates a test container, which is a process it uses to coordinate other containers, and then it creates my SQL Server container here, and once the tests are done, it removes the containers afterwards. This one will leave after a while in case, but checks out in a little bit while to see if something's happening. And you get test containers for all kinds of things. You get RabbitMQ for messaging, all sorts of fun stuff. Right. So I have a small task for you. If we go into our source, we have in customer, there's underneath data, there's a customer DB context. It has the customers as a thing here. So let's expand that. The thing I want you to do, and you can choose if you just want to go ahead and do it on your own, or if you want to follow me along as I do it here. That depends on you, or if you just want to lean back and watch me do it, whatever is fine. Whatever you want to do is fine. I want to make similar stuff for catalog. My catalog doesn't have anything in it, so I'm going to start working on my catalog. So we're going to just make a new folder. Oh, not that. There we go. So I'll put my stuff in the domain. Okay, had a weird, this is what I get for running previews. So let's open my folder and File Explorer. There's my catalog. So there is a bunch of folders here, it just won't show them, which is cool. Show all files. Great. Because there's nothing in it. So let's add to this here. Oh, okay, great. So we'll make a new class. We'll call it catalog item. It should inherit from aggregate root. Because it should be the root of a thing. I'm going to be really easy with this one. It's going to have a string name. That's pretty much it. Start out with a blank name. Just to have something here. Doesn't have to be anything. I'll move that into my domain folder and adjust the namespace for that. Now let's make catalog DB context, which inherits from domain DB context. And I'm a lazy guy, so I just copy stuff. Right? So we'll just do that. This is from, and here's the thing. My customer DB context is red. I can't reference it. Why can't I reference it? Anyone notice why I can't reference it? It's internal. So my customer DB context is internal, which is a keyword that you said this thing here is only available inside this project. It's not available anywhere else. This prevents what we call, us Norwegians like to call the Norwegian arm. The Norwegian arm is, so in Norway, it is considered more polite to not bother someone when you're sitting by the table eating than stretching into their personal space and grabbing stuff. But bothering them saying, could you pass me that thing, is sometimes more awkward than just, I'm just going to lean over here and take it. This arm is referred to as the Norwegian arm. It is a quirk in the Norwegian culture where we'll just grab things across the table. Other people from other countries go, what the barbarian shit is this? So the Norwegian arm is a thing. We don't want Norwegian arm in our code. We don't want piece of our code just stretching into someone else. I'm just going to go over here and grab something. So now you have a meme at work when someone, well, oh, that's a Norwegian arm. And people go, what? And you can tell that story. So to prevent Norwegian arms, we have internals for a bunch of stuff. Catalog DB context. We're going to implement some missing members. There's our schema, right? We need that. catalog. Great, let's put that in there. That's pretty much all I need to do, but it's kind of not very useful without any data in it, so I'm gonna have some catalog items here. They're always useful. And we're gonna do the on-model creating, and I'm gonna set that it has a key of ID, just to make sure that works. So based on model creating model builder, we'll call my domain DB context. I like to call that first. It just makes me feel better, but you don't have to do it. I'm going to say for catalog ID, this has a key. That works out great. So that's my thing. Now, I need to register this somewhere. It needs to pop up somewhere. Well, I'm going to register my module in my module. So in my, let's go to customer. I have a folder called hosting extensions. Here I have a registered customer module. It has two methods, add module and use module. Some of you will recognize the add and use verbs as those that are used in program.cs, where we used to be program CS, and then it was configure, and then it was startup, and it was all kinds of everything, but it's always been two separate parts. We add a bunch of service registrations, and then we build the host with all of the dependency injection and all of the services configured in. And then we use that host. And we use different parts of it, adding in different middleware in our requests. So there's an add module and a use module. These both come from the iRegister module interface, which has add module and use module. And then I can have various extension methods on my application builder. And here I can set up my database, for instance. I can add some custom middleware if I want. So ASP.NET has a concept of use when. So only use this when the context path starts with /API/customer. And then I can have some middleware here which is valid only for the customer context. So I can add stuff to my web application by just working in my customer project. Cohesion. I'm keeping these things together. This middleware doesn't do anything. It could log a request or do whatever, but it would do something that was particular that it only needed in the customer context, and I didn't want it to bleed out to the other contexts. So we can use when to register middleware for just particular places. I also have endpoints. We talked earlier about how we have, I can have Razor pages in a separate project. I can have endpoints here. I could have controllers, MVC controllers here. I happen to like endpoints better. I like the more lightweightness of them. So I'm a big fan. So here I map a group /API/customer, and I turn that into a root group builder. And then I have a bunch of paths here. All of these paths are relative to this path. This is equivalent if for MVC, where you have the route attribute on your controller, and then you have your route attribute on your actions, which, unless you have a slash in front, is tacked on to the wherever attribute you have on your controller. For this path, call this method. For this path with an ID, call this method. For post to this path, call this method, so on and so forth. And these are just methods down here. We'll get back to those later. All of the registration, all of the stuff I want to do with the customer, all of that exists in the customer module. All of that infrastructure. Again, being lazy, I'm going to copy this. Actually, I'm just going to copy the whole file. Let's copy it into new folder. I'm going to copy it into endpoints, actually. And I'm going to change the name of endpoints to hosting. Update some namespaces. Implement some missing members. What are missing members? Oh, yeah. We need some, import some resident files, using statements. And again, customer DB context doesn't work. This is the catalog DB context. Go. I'm going to drop this one for now. And I don't need all this middleware. I don't need the logging. I don't need the endpoints. So I'm just going to delete all of those. See, these are gone. And I'm going to just replace customer with catalog in current document. There we go. Something is failing in importing this stuff. Let's go to the catalog project. Framework for core. .SQL server. ** to get the latest version, not the one with security flaws. And if we now drop into hosting extensions, everything is good. Now I made this hosting extensions part here. That worked out nicely. Now I should probably go and hook this up in program.cs, except I don't have to. Because one of the things that makes life easier to work with is not having to do stuff. And in program.cs, I have a module registry. It says add module services. As your application grows, one of the ways to make things easier to work with is introducing a bunch of conventions. Saying that, hey, we're going to do it this way. And if you do it this way, then everything just falls into place. In this case, my module registry has a method called discover modules. What it does is that it goes through my base directory, finds all my DLL files, finds the one that starts with commerce.feature. And just loads all of the types from those assemblies. Find all the types that are of type is assignable from iRegister module and is not an interface or is not an abstract class. Create an instance of that module and put those in a list. Those tabs, okay. I'm going to pin that and that. And then we're going to do close all but pinned. So since my register catalog module implements iRegister module, it is automatically discovered and put in that collection. So when I in program.cs go new module registry, which has modules internally and says initialize to discover modules. I can do add module services, which goes through all of my modules and calls add module. And then a little bit further down, I have use module services. It goes through all the modules and calls those. Using reflection is a really neat way of making things just fall out of your app. There's many ways of doing it. You can just load all your assemblies. You can do filter on those. Filtering from disk is an easy way of doing it. There's no wrong way of doing it. It all depends. Reflection has consequences. It means you cannot use AOT, ahead of time compilation, because that will trim your application of all the code that is not directly referenced. So anything you discover by reflection will not be there afterwards. So if that's important to you, then you can't use reflection, then you have to do something else. It is a little bit time consuming, so your app takes a little bit longer to start, but not really that much. And in the grand scheme of things, it doesn't matter that much. A couple of network calls and you more than wait up for that time. So making a new module and start of a new module now involves making some DB context, making some domain objects, and then registering the application. Now we need some way of talking to our domain. My wife wants to reach me. We have your internals and externals. So in your application, you have your domain objects. Those should be unencumbered. They should not worry about infrastructure. They should not worry about where data is coming from or anything like that. They are your internal objects. On the outside of that, you have your application layer or application circle, depending on how you like to draw your diagrams. Those are your external facing parts. And then you have whatever's outside. And whatever's outside includes all the other contexts, all the other modules, features, whatever you want to call them. I like using Mediator. Anyone familiar with Mediator? Yeah, pretty much everyone. So if we go into customer, there's, I like putting one use case in each file, and I put them all in the application folder. So the create, for instance, this is for creating customer. I try to follow conventions. So I'll have create with a command if it does something, and a query if it gets something. It can be whatever you want. It doesn't matter that much. But again, I'm writing code for other people. So when you're looking at the code somewhere else and you're seeing send get.query, I know that that thing has no side effects. It's a pure query. This involves a create.command. Something's going to happen when I send that. I can tell immediately from the usage here. I have a static class that I nest records and classes in, which makes me able to separate these. I can have a bunch of commands and I separate them by the class name. So it's create.command, it's update name.command, and I always return a response. let's say, for instance, get. So my response here is not a customer object. My response is a name, is a record called response with a name and an email, both strings. This is information that's going to go outside of my context. I'd never pass my domain objects outside my context. In fact, my customer object is internal. Your domain objects should not be available to other contexts or other features or modules, because then they start taking hard dependencies on your module and your internals, and they prevent you from working and iterating and making things happen the way you want. So say, for instance, I want to change my customer name. Now I have a name. I want to change the first name and last name instead, although that might be a bad idea. Names are really, really weird, and whatever you think you know about names, you're wrong. There are, I used to work with a guy, his name was Fnu Anshumali. And I thought, Fnu, that's a weird name. It's not his name at all. Because he comes from a place in Sri Lanka where they have one name. They only have one name. They don't have a name, a family name, or multiple names. They have one name. It's a really long name, but it's one name. So when he moved to Norway, and they're like, yes, we're gonna put you in the registry. What's your first name? I don't have one. My name is Anshumali. That's it. So his first name is Fnu, which is short for first name unknown. And if you go Google, you'll find on different pages, you'll find a bunch of people called Fnu for first name and Lnu for last name unknown. Because they come from cultures where you only have one name. Some people write their first name first and last name last. Some other cultures write their last name first and the first name last. It's very extensive. The easiest part with names, just give them one field for name and let them put whatever they want in there. Don't worry about it. But in this case, someone in their wisdom decided, oh, we're going to split names in two. So we're going to do first name, and then we're going to do last name. And for some reason, we decided just to get rid of this one. We'll initialize these to blank so that they are never null. Now I'm changing my customer object because I have business reasons to do that. What I don't want to do is break everyone that depends on my customer somewhere. Which I can do, I can go into get here and say, okay, this new response, it used to be name, but now it's C first name plus a space plus C last name. My internals have changed. My externals have not changed. Everyone who depends on the customer having a single name can still work the same way. So all the pages that use a get and a customer to get stuff, or the APIs or the mobile apps or whatever that interface with the API, they all stay the same. Yes?
We're using also aggregate routes for fetching the data.
You're using what?
The aggregate routes, are you using them for fetching the data?
Yeah.
Okay, yeah.
So now customer is pretty thin here. We don't have much here, but say let's say we had public parent or something. Let's say manager, for instance. Doesn't matter. It's a navigational property, or you can have a customer. We're going to have a list of customer. List of customer with friends. We're all friends here, right? I will probably implement this differently as a read-only list with the backing field and all that, but it doesn't matter. What you can also do here in your get is that we can control what data we get. Entity Framework is by default lazy. It does not get all the related collections. It gets what you ask for and that's it. But I can here say, well, in this case, I'm going to include c.friends. So I'm saying, hey, get this customer, and while you're at it, get all the friends in. And we can do stuff to prevent joins. We can add stuff like, where is it? We get that not here, but it's earlier. I usually have it defined somewhere else. A split query, which will make it do 2 queries instead to do relations instead of doing a bunch of joins, which will usually have a better performance. I can add stuff. Since this is just getting stuff, I can do as no tracking. Because I'm not updating anything, I'm just getting stuff, so I'll skip the entity framework change management for this one, do not track. And then it can grab onto those, make a little bit for me. I can do all of these things here in my domain and decide how other people get to use my code. Yeah, we'll just keep that. Another thing that is really useful with Mediator is the behaviors of Mediator. Anyone use behaviors of Mediator? Yes. These allow me to define behavior that will happen pre or post a handler, and I can, through the use of generics and through the use of marker interfaces, I can say, have behaviors that only trigger for certain messages or certain handlers and certain queries. For instance, we have a handler where we have a marker interface for our queries as I have user, and it has a user ID. And we have a handler that whenever that comes in, it will grab the user a user service that will pick up the user ID for the current logged in user, populate that field, and then pass it on to the handler. So when it comes into the handler knows that this field is already populated. It doesn't have to bother with any of that stuff. It's just handled somewhere else. If I need a user, I'll say, I have user ID, and then add a field, and it just works. You can do stuff like logging, and do validation, you can do error handling, you can do exception logging, exception handling, all kinds of stuff in here. Since you're all familiar with that, that's very sweet. There's also, I like using mediator handlers, but you don't want to call a handler from a handler. That is by definition unsupported, and behaviors are the main reasons why it's not supported. Because when you call a handler with behaviors and then that handler calls another handler that has behaviors, you can get into weird situations, which you don't want to do. So sometimes we're going to need a service. And a service can be useful for intra-context communication. So how do we communicate between our contexts? Well, one of the ways of doing it is just simply creating, let's add a folder. You can add multiple services, and so one of the problems with services is that usually get really large. So you can combat that by creating more targeted services. You can say, for instance, we have customer information service. That's our thing. And that should probably be an interface somewhere, because we want people to depend on abstractions and not concrete implementations. And there's the thing, where do we put our interface? We can't put these in, some people put these interfaces in some kind of common library, where you have up here, we have there, and then we have add new folder, services, and then I put that, oh, actually I don't copy it. Move it into services. Might take a long time. There we go. And then we update the namespace. So we can do that. Now that interface is available for everyone. And everyone can get that interface. And if we register it, where do we register it? Well, we register it in our hosting extensions. Add catalog services. Or this was that the wrong one? We were at customer. Yeah, we're at customer. So we go to customer hosting extensions, where we have our customer service registration, where I just go builder.services add scoped customer information service gives me customer information service without the I. Again, I'm working only in the customer context here, except this common part. Another thing that some people do is that they create a different project. Do add new project. Do a class library, do commerce.features.customer.contracts. That in our source folder. This is on .NET 8. So now we have a contracts project, and we can say, well, this contract project, everyone can depend on that. That's great, that's fine. Let's everybody depend on the contract project. And then we can, we put stuff in there that we want to share with others. If you're gonna go all the way with this, you might want to consider the way you organize your, these things, because maybe you want to move the response objects into the contracts so that nobody can depend on anything in your domain project. So the whole customer project is off limits, and you have very specific classes that, like the commands and the response objects that they can respond to. I'm not a huge fan of that because it breaks cohesion, I think. You're taking something that is very tightly knit, the command coming in, the handler and the response coming out, which are very tightly knit to that particular use case, and you're smearing this out of your app. So I'm not a fan. Yes?
The interface in the same customer project and make it public, but the implementation is internal. So in that sense, you expose only your public APIs, and internals are internals.
Yep. So the comment was, well, what if we just keep our service interface here? And we keep our interfaces public, right namespace. And then we'll go to our service, and we'll say this thing here, that's internal. Now, nobody can instantiate this service from outside my context, but anyone can reach in and grab this thing. The problems that was asked in one of the breaks here was the problem of how do we access, now we talked a lot about how we prevent people from talking to us, but how do we actually share data between contexts? Well, one of them is duplicating data. So we have an identity context. That's our application user, and which inherits from identity user and everything, which has the identity of the person logging in, which is not the same as customer at all. So our customer is a different thing than the login identities. And in ordering, on an order, we need some customer information. And we might need some user ID of some kind as well. And in shipping, we have some shipping labels and information. We're going to need a customer there as well. So how do we make sure that these are available? Because we can't reference our customer object from ordering. I can't just draw a line all the way here and say, oh, we need one of these. Because I want to evolve my customer here, again, without affecting the others. And I don't want this huge God object where I have this one customer object that has concerns from the entire application system. That's how you get these massive classes with lots of different stuff. Just looking at, for instance, our, there's Visual Studio. Go to solution, let's go into customer identity, there it is. Go into domain, here's application user, which inherits from identity user. And identity user has a bunch of stuff. So there's, this is where we are. Oh. Lockout enable, lockout and normalized email, normalized username, password hash, phone number confirmed, security stamp, two-factor enabled, username, email confirmed, email concurrency stamp, access failed count. None of these things are interesting for a customer. And yeah, this customer and this user are two views of the same thing because they both represent, you can't have one without the other, love and marriage kind of thing. But we call them different things. Like I said, the boundary context is the boundary of meanings. So in the customer context, customer means something, and the identity user has a meaning. They're the same thing, or pointing at the same concept, but they're different. They have different things to them. And in ordering, a customer here has different characteristics than a customer in the customer context. Customer context might have a whole bunch of stuff about where you live, the past addresses we've had, different relations, all kinds of stuff. Maybe aggregate some information about how good a customer are, what kind of standing do you have, what status do you have. None of that is interesting in the ordering or the shipping context. We just want your name and your address. That's it. That's all we care about. So how do we keep these in sync? One of the better ways of doing it is using messages. So a customer appears in a customer repository. This sends out an event. Customer created. That event can be picked up by multiple contexts. And here's one of the cool things. Without the customer context even knowing that it happens, it doesn't care. It just says, hey, I created a customer, whatever. If anyone interested, there's some information on the table over there. Like, go figure. I put some papers there. And you guys could go over and like, oh, okay, one of these. Oh, I'll take one of that. Oh, great. But we have to make sure we know where do they come from. Who is the master owner of who has the authority? When a new customer is created, is it created from the user context first? Does it happen when someone goes to our site and registers as a user? And when a user registered, they come into, they're transferred into, we need some more information about you, and then we also create the customer based on that information and connects it to the user? Or do we create a customer because there's some account manager sitting at his desk somewhere and calling someone and saying, yeah, no worries, I've got you registered in our system, I'm gonna send you some information that you can log on through. And so they create the customer, and from the customer they create the user. So which direction does the data flow? You need to have that clear, and you figure that out by talking to your domain experts. Because that kind of information should just go one way. Updates should go one way, and that's from the source. I never update the customers in these domains unless I get a message from the customer domain that a user was updated. I'm going to make it equal. So how do we do these things? Well, some of you might have noticed that on my aggregate root, I have a collection called domain events. And I can add stuff to it, and I can clear it. Interesting. So in my customer, which is broken because it doesn't have a name anymore. Instead of fixing it, I'm just going to add name back. Because you didn't come here to watch me fix code like that. So, I like using create methods for creating stuff because then I can do stuff in those as well. But in my constructor, let's see. So I'm going to need a constructor here somewhere. Let's do I'm going to make a constructor for all of these. And I'm going to say raise domain event, new customer created. And I'm going to add the name, the first name. Actually, I'm just going to add the name and the is active. My customer created type inherits from domain event. I'm going to make these over here. I'm going to introduce some auto properties for those. So this is a domain event. So my domain is responsible for saying, hey, this thing happened. Something happened now. A customer was created. I can make multiple events. I can say, for instance, when a thing is deactivated, it's activity false. Raise domain event, new customer deactivated. And I forgot to bring in the ID. Oh, it doesn't, GUID doesn't go here. I'm not making the class. Create the type, customer deactivated, domain event, takes in a GUID ID. And we'll go introduce a read-only field. No, actually we'll introduce a read-only property. And convert that to a primary constructor. There we go. So I'll have these things, and I want an ID here as well. GUID ID. That in. Name. True. That was all of those. Name. First name. Last name. Active when creating. Oh yeah, we don't have a first name here, of course, so we'll just go like that, just to make it compile. Not the point. The ID events are the point. So I create these events, I raise them, I put them into collection. As I work my domain object, I raise these events. Now I pick those up again in my domain DB context. Because here I'm overriding save changes. And I'm saying, hey, Entity Framework keeps a track of all the objects that it loads that are available for changes. It keeps those in its change tracker. So in the change tracker, find me all entities of the type aggregate root where there are any domain events, and select those entities. So I get a list of entities with events. And then I send those off to an event dispatcher. And then I save changes. This event dispatcher will take in a list of aggregates, select all the events across all the aggregates, put that in a list, and then clear all the events from all the aggregates. And then I publish those events through Mediator. You had a question?
Anything to the database, and I just use my domain objects, and I want to raise a domain event, but I don't save something to the database.
So the events are always in response to something that happened. If you don't save anything, then nothing happened. What you're looking at is a command, which is a different thing.
Send something to another service, but I don't save to my database.
That's a different thing. I'll get to that. So events are always a response to something happening. Something happened, and I want that to, and I want to tell the world about it. And then the world can figure out what they want to do with it. I have no control over events. The mediator publish returns just a task. It does not return any information at all, because I don't know if anyone actually reads these events at all. Then we can make mediator handlers that can pick these up. Now, these are domain events. They should be only available within the domain. So these are internal, as they should be. You should not raise domain events outside your domain. Why? Because these things happen in the same transaction. So, looking at my domain DB context, I dispatch my events, and then I call save changes. So, I call save changes from my mediator handler. I go to save changes here. I dispatch events. Other handlers, notification handlers, pick those up, process those events, make changes. They call save changes. Save changes called again. Did any other events happen? Then they are dispatched. And once all the side effects are gone and no more events have been raised, then we start calling the actual save changes. And then all of the changes are persisted. If I get an exception somewhere along these lines, then nothing happens. Because then none of the save changes are being called. These are all async await, but they still happen sequentially. They don't happen in parallel.
Will it be the same it will be sub-transaction, or it will be a different thing if you have?
So it will be one transaction that will the first save changes will save everything, because it's the same DB context and has all the change tracker. So the first time you call this, it will save everything, and then all the other ones will be called, but then the change tracker will be empty, so it's basically a no-op. And every save changes puts all the when you call save changes, all the pending changes are put in one transaction, so that everything completes or nothing completes. You don't want to do that across domains. So you don't want to use this mechanism with mediator published in process across your modules or across your bounded contexts. That is a road to sadness, because then you're doing something and then you're catching something else, and that calls a different DB context, and that maybe saves, but then you come back and something crashes on your end, and then this doesn't get saved, then you're halfway in between. You have something that happened in one context based on something that should have happened in the first context, but didn't actually happen, and you have divergent data. So you need some form of mechanism to pass these messages along in a different way. What you do is that you use what's called the outbox pattern. And is anyone familiar with the outbox pattern? 2, 3, 4, 5 people. The outbox pattern is that I have my thing, something happens, I publish an event inside my domain. I pick that up through a handler, and I take that event and I persist it in my outbox. Then I have a process, a thing, sitting on the side that watches my outbox and says, ooh, there's a new message in my outbox. I'm going to grab that. And then it takes that message and publishes it somewhere, often on some kind of bus or message queue or whatever. And from here, other people have said, hey, I want to subscribe to customer-created messages. So if you have anyone, let me know. And this mechanism, this central message broker, could be RabbitMQ, Azure Service Bus, AWS has it was SQS, something like that. We use RabbitMQ running locally, and we use Azure Service Bus when we're running in production and dev and test environments. Works swimmingly well. That part is responsible for taking care of this. So this background job sees, oh, there's a message in my queue, in my outbox. I'll pick that up and I'll give it to the message broker, RabbitMQ, for instance. RabbitMQ will persist this message, let me know that I got it. I can now mark that message in the outbox as handled. It is now persisted at the second location. So the first persistence in the outbox happens in the same transaction as the actual change, because that is handled internally in the domain through the save changes and the event dispatcher and the notification handler picks it up, saves in the outbox, along with all the other changes. So the message is persisted in the outbox in the same transaction as the actual change. It is picked up from the outbox, passed to the message bus. Message bus says, I got this, don't worry about it. And then I can mark it as done, and it can be passed along. it will now try to deliver this message to all the ones that have said that they want to subscribe to this message. If it cannot be delivered for some reason, it will retry, and you can configure it saying that messages that cannot be delivered within a time period, they go into the dead letter queue, and you can handle them from there. Essentially, your message will not be lost. It will be persisted, and it will reappear, and it will be retried, and eventually it will get there. Even if you make something completely wrong and your code just times out, it will go in the dead letter queue and you can pick it up after 24 hours or whatever, and you can say, okay, I've made some changes, now I can push this, and we're good. Doing that is not a super amount of work. You can do stuff with, for instance, mass transit, which is an open source library, where you would have, let's see, you would create a publish endpoint, endpoint with mass transit that publishes messages to somewhere, and that's basically just a handler looking sort of like this. Let's do in the let's add a folder. This is in customer. Let's call it event handlers. Let's add a new folder. No, not new folder. Let's add a class. Let's call it order created customer domain handler. Lack of a better word. And we're going to get a bunch of red squigglies here because there's a bunch of code that isn't included, but it doesn't matter. It would look something like that. You have domain handler takes in a publish endpoint, which comes from a mass transit. And then you have customer created event notification, and you just publish this message into some kind of interface that you've created. That's all you need to do. Mass transit takes care of the rest. Depending on how you set it up. Through configuration, you can set it up with the outbox pattern, and it will solve all of those things for you. You publish it there, it will put it in. You can register that with your entity, your DB context. It will create the tables for you, and it will store and will keep and watch, and we'll have a background worker running to keep track of the outbox, and it just handles all that stuff for you. The thing you have to do on the other side is you have to make some kind of consumer. So for instance, for catalog, or actually we can go into identity. You would say, let's add a new folder. Consumers class. Customer created consumer. That consumer looks a lot like your regular event handler. Looks a little bit like something like this. This is for a different context, but it doesn't. The concept is the same. It implements the interface iConsumer, takes in some DB context. You get the event. What do you want to do when that happened? Do whatever you want. Add it to it, save the changes. So it's pretty much like a mediator handler. So mass transit is a little bit of work of setting up. You have to register the background worker. You have to register the little the outbox patterns, but you can do those in the domain DB context, so they just follow every single one that inherits, gets the outbox, and it also has an inbox pattern if you want. And now you can do that kind of communication. The other thing we asked about was, how do we do stuff when I want something to happen, but I don't want to do it myself? Which is typically when we interface with third-party services to do something for us. So something happened in my customer thing, and I want to send a good old email. How do I do that? I don't want to do that in the same request that something happened. So when someone registers on my page, they create a user, I want to send them a welcome email. I don't want their registration to be dependent on some SMTP server actually working and being available. I want to put my stuff, I want to leave an intent somewhere, and then I want that thing to happen. That is what we use queues for. Queues are different than message bus or events. Queues are basically commands that you put on a queue, and they're handled by consumers. You can do the same thing. You can use mass transit for queues as well. You can use RabbitMQ or Service Bus. It's pretty trivial to make a little implementation that will put things in a queue, and you can have a RabbitMQ and a Service Bus implementation for it if you don't want to go all mass transit and all of it. But the idea is that your request creates this event, and you can even put it in an outbox pattern as well and store it somewhere. Just, hey, I create an intent, send email intent, put it in a queue outbox, and then have a background worker that picks those up and does the work. You don't even have to have RabbitMQ or anything else. The trick is that you leave something in a queue or in a table somewhere, and then you walk away. And then you have something else, pick that up, talk to the SMTP server, which might be slow, might take a while, might need some retries, isn't available this week, is back again in 3 to 5 business days, nobody knows, you talk to support. Eventually it will go through. Have you noticed how the word queue is just a letter Q and then 4 silent letters just lining up after it? They're not pronounced. So events, you use those for intra-domain communication about things that have happened. You can use events for that sort of thing as well. You can say, hey, when a user has been created, I have an email context, and I want to respond. I know what email addresses people have. I know what email should go in which different cases. That's not the customer domain. Don't need to know that. The customer domain don't have to care about how do we talk to our customers. That could be our marketing domain. Here we could set up different procedures, different tracks that when you sign up for these 4 emails, and we control here how we should nudge people. When they've done these actions, then these things should happen and they should get these emails. That could be in a totally different domain, all of those decisions, and it could respond to events. So whenever a user created or user registered, you have the marketing domain picks up the user created event and then sends an email. And if the email isn't sent, the server's down, you don't acknowledge the event, so the message bus will retry. So you get that retry mechanism for free. If you don't want to go all in with mass transit, there's the whole thing. Oh, I guess I did. They are, let's see. Go. Hangfire is a thing that is also kind of useful, especially when you're starting out. It's a in-process scheduling service with queue functionality. It's basically, you can run jobs, background jobs on cron jobs, but it has a queue functionality where you can just give it a job or start a job with some information, and it works pretty much like putting something on a queue. And it has retry mechanism, it persists the jobs across server restarts and everything. So it's a nice, easy way of getting started with some async handler with very little work in your application, and then you don't need any other servers or anything like that. If you want to go further, Brighter, Ian is in charge of Brighter. He has a session tomorrow on doing microservices right. So if you get to the point where you actually want microservices, then sure, he has a lot of information on how to do that right. And there's another guy on Friday, I think it is, which has also a session on microservices, doing it the right way. Mass transit and service bus, two mechanisms that libraries that sit on top of a message bus, enabling you to do a bunch of stuff. Last thing, the Norwegian arm. We talked about using projects for preventing the Norwegian arm. We can have contracts, we can use internals, we can do all of that stuff. You can also write tests for this. There's a project called ArcUnit, which exists on a .NET version, where you can write tests where you can say, hey, these patterns or anything responding to this, matching this namespace pattern is allowed to talk to services in this namespace pattern, but nowhere else, for instance. So then you can have tests that actually fail if someone tries to break the rules. I'm just going to mark this interface as public, like couldn't possibly hurt. Or maybe they missed it and they human error. Then you can trust, but verify. One of the advantages of doing all of this is some say, well, yeah, now it's easy to break out into microservices if we want to. That's not really the point. Sure, it makes it easier if you want to go into microservices, you need to go into microservices, and then there are 3 good reasons for doing that. Talk to me afterwards if you want to know which ones. But the main point of this is that it just makes it so much easier and nicer to work with. Because you can go into one context, which is small, well-defined, easily understandable, look at small use cases and see, oh, that's what's going on here. You go into mediator handler, they'll usually fit on one page. All the infrastructure is handled for you with pre and post behaviors. Just go in, fix the business demand, go out again. That is the big advantage of doing things this way. And keeping that complexity low because it's contained within a single module. Lots of complexity removed from you with automation and conventions. Yes?
Tool name you used to test?
ArcUnit. Like Arc as an architecture. So ArcUnit.net. I don't know if it's that, but sure. Whatever floats your goat, man. I'll be around for the full conference. Find me. Email. For those of you who moved to Blue Sky, that went away from the burning cesspool of dumpster fire that Twitter has become with engagement, bait, and rage. But I'm still there as well, so you can ping me there as well, or send me an email or whatever if you want to talk more about this. I think you get some messages in that, like the Pine app thing that they use. I have no idea if I get notified, so if I don't respond, it's not because I don't like you, I just didn't get the notification. So, find me, ping me, grab hold of me if you want to talk more about this. In 10 minutes, there's chess, chat, and cheers outside in the lobby. I have no idea what that means except the chess part. Any other questions at the end of the day? Yes?
But you didn't express your feelings or opinions about it.
Oh.
To exceptions.
I use both. So the result pattern is, instead of returning just an object, you return a result. That is either a success or an error. And if it is a success, it has a payload, which is the thing you actually want. If it is an error, then it also has some information about that error. I use the result pattern for errors that are expected. It is expected that a customer is not found, for instance. That is normal. We don't know. You try to look up something, didn't find. It is expected that the thing the information the user gave me didn't validate. That can be expected. These things happen. I like using result pattern for that because I think it makes a nice coding model and is easy to read. You can have very expressive error objects that can also easily translate into errors in the UI. So there's a whole bunch of things I like about that. And then you have unexpected errors. Like the database is gone. That is unexpected. That is exceptional. That's what I use. I use exceptions for exceptional errors.
500 error on the client.
Yes. So exceptions return a 500 errors. Like, yeah, this thing. Well, actually, we give them a nice little page that says, "Hey, this stuff didn't work. We're sorry about it. It was not your fault. There's nothing you can do. We've been notified. We're going to try to fix it as soon as we can. If you want, here's a code you can send us if you want some feedback on this particular error." So we don't just give them a 500. Fuck you. Which some people do. So we call them wah page because it says wah at the top. So somebody got a wah. But the other ones where we expected errors are something the user can do something about. So any error you give to a customer, to a user, should be actionable. There should be something they could do about it. It's not like the dumbest thing is like something unexpected happened. Okay. Now what? Like tell them what to do is like either please wait and try again later. We're trying to fix it. Or like there's nothing you can do here. We're going to fix it. You can contact us this way. You can. So there should be something for the user to do. Or it should be, hey, your email doesn't contain an @ sign. You should fix that. Although an email doesn't have to include an @ sign. So we had one issues with validation of email. I know what validated emails. That's fun. So we had a bunch of people that signed up with email address first name @online. That's it. Because in Norway we have a service provider called online.no, and they just said email name @online, no .no. I was like, what? How does this happen? Because we put in the ASP.NET email validator, which is built into ASP.NET for that field, and it should validate it both on the client and on the server with the model. And so why does it turns out that it's a perfectly valid email address. Name @machine. That's a perfectly valid SMTP email. It perfectly valid according to the RFC. It just doesn't work in real life. But it's valid. So yeah, validation is fun, but then we had to change that. And say, hey, you need a bigger, your email address is wrong, please fix it. So yeah, I use the result pattern for those things where I can give the user something meaningful, a meaningful response back, instead of exceptions. Sometimes exception nice though, because something happens down here and I can catch it way up here, which is nice. The result pattern, you have to pull it along the whole way. So, but it also lets you do railroad, where you can do a bunch of things, and you can, with failed here, we'll just skip the others, and you can do a bunch of things with that pattern. So, it's potato, tomato. I use them both for different purposes. You're all free to go, unless you like, if you want chess and cheers. Yes.
Another one, which is maybe a bit more controversial, is about using interfaces with a single implementation, like we did in the service example.
Yeah.
Yeah.
So the point is abstractions. Yeah, the point is abstractions and decouplings. You only have one implementation until you want to unit test something, and then you have two implementation. because you have the implementation that is there, and then you have the implementation that you don't want. So for fakes, mocks, and stuff like that, yes, we can do a lot of that with just overriding classes and making methods virtual and stuff like that.
One interface and one service, and you have a million interfaces that have only one implementation. Why don't you wait for the second implementation to come and then decide the contract and extract an interface?
So
From the beginning, that's the question.
yeah. So in this case, I would have to expose my service, the customer service, the whole customer service would have to be exposed to everyone else, including what that was doing and so on. It's not a big thing. I like depending on it, on interfaces instead of concrete implementations. But it's not I don't have a good reason for it. I'll try, especially if it's services that are not used. So if it's things that go across domain boundaries, I like having interfaces. But we often have services that are used internally in a domain. I rarely put interfaces on those unless I really have to.
Move to a microservices architecture, then you'll have to do something about
Yeah, you'll have to do something anyway.
Interfaces, right?
So and it probably wouldn't be the same anyway because you have to change some things. Signatures would change, the way you create it would change. We had one issue with what was it? There was one mocking. Was it n substitute? Or no, it was specs 4, I think it was, which did not do well with overriding classes without that didn't have interfaces. So if you had a concrete class, because you can just inherit from a normal class and just override methods and make your own mocks and fakes and whatever. You don't need an interface to do it. Specs 4 wouldn't do that. They did not play well with that at all. So we got a bunch of interfaces because of that. We moved to and substitute and auto mocking for a bunch of tests, and they have no problem with it. So now we have a bunch of test services that don't have an interface.
Right, because you said.
Yeah. So it makes unit testing a lot easier. We're just saying, here's an interface. I'll make a mock or whatever. I'll just pull up a small class, implement that interface, toss it off. Sometimes you can have larger classes that have 2 interfaces, depending on what you want. We use interfaces a lot also for marker interfaces, for just to tag a class with something. Like so we use interfaces for that. But I don't have strong opinions on the interface per class thing. I know people go, C# like interfaces everywhere. It's like, so? What I don't do is I put them in separate files unless I have to. I like keeping them just, if I have, I don't know if I have one here. But I think it's over here with infrastructure, the module registry. So here's the module registry, and the iRegister module is right next to it. It doesn't make, for me, it doesn't make sense to have this in a separate file. It's just noise. It's so tied to this thing and the way the implementation of it that it just makes sense for me to have it here. That is actually inherited. That is not the interface for that. It uses those. So this is the marker interface that it defines them with. But it's defined here because everybody needs it. So the references here are in the iRegister module for register customer module. So yeah. Anything else? Let's go get some chairs and chess.